more than 50% of the leg length for more than 70% of the duty cycle, so it can run over things. Okay, and it's just being shaken by its hand right now. It's a very light leg, and we think it's going to run very fast. This is our initial simulation of a robotic ostrich. This is a planar dynamic model, fully dynamic model that's running at 20 miles an hour. Mostly just driven by a motor here and tendons through the legs. Now this terrifies me, the bandwidth requirements for the controller, the model requirements for the controller. But the amazing thing about this video is that all these videos that you're seeing right here are all open loop stable. Yeah. So the leg is smart enough, it's got springs in the right places, it's actually open loop stable running. As you can see, it runs over this kind of stuff here. So now I think the burden has been reduced a little bit for the control system. So we'll see. I'm also sort of have these nightmares now of coming into the lab and just seeing like the imprint of the robot on the wall. Sort of why they give us, we don't really have space to work on that, but we're going to try.
How many actuators are there?
Just one in each head, so two actuators. Okay, I'll take any questions. Just
between some of this funnels verification that you're talking about and the sliding motor control?
Yeah, so I mean you can think of I'm sure there's straightforward connections that any sliding motor controller should have a the optimal function representation, but I haven't thought that through actually. Yeah, we should write it down. I haven't thought it through yet.
So as far as real-time implementation, you guys definitely run this on your laptops. You guys try doing any like implementation on thumbsticks or maybe even smaller?
So the controllers that are produced are very simple to run. They're linear controllers too. But the verification I wouldn't run on thumbsticks. That's why we're trying to pre-compute things and pre-compute them generally enough. Maybe there's maybe the next row of thumbsticks is going to be running something squares. I don't know. Or maybe we'll convince Google to write STP solvers and we'll just talk to the cloud and solve our STP to all the things. So the policies that come out, very simple, very lightweight. The design process, not lightweight. Yeah.
So off the grid, what do you need to know about the forest?
So we're looking at both spectrums, from the pure, no information, just getting runtime sort of trees. We're going to plan, we're going to pull out of our library of funnels something that just gets me in a receiver.